In this lecture, we are going to look at how to find the maximum and minimum return of a portfolio in code. This lecture is going to walk you through a prepared Colab notebook, although a very good exercise, which I always recommend, is once you know how this is done, to try and recreate it yourself with as few references as possible. As always, you can check the lectures, how to code by yourself, and how to practice for a more in-depth discussion. If there's anything in this lecture you didn't understand, or you think I missed a step, or didn't explain why we were doing something, please use the Q&A to inquire. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. Let's start by importing the linprog function from SciPy. Next, let's get D, the number of assets in our portfolio. This is equal to the length of our mean return series. Next, let's set AEQ and BEQ. These are defined as per the previous theory lecture, so hopefully you took notes and you recognize why these should be set this way. Next, we're going to set the bounds. To be consistent with the other parts of this notebook, we're going to set a lower limit of minus 0.5 with no upper limit. The bounds argument should be an iterable of length d, and each item inside the iterable should be another iterable containing two items, the lower bound and the upper bound, for each variable in order. Now that we have all our inputs set up, we can call the linprog function. The first argument is the C vector that goes into the objective. We'll do minimization first, so this is just the mean return vector. Next, we pass in AEQ, BEQ, and the bounds. So let's run this. Okay, and we get a message saying that the optimization terminated successfully. So what else from this output is useful for us to look at? We can see from the fun item that the smallest return is about minus 0.195. We can also see from the X item the optimal value of the weights. These are to set the first, second, and last asset to the lowest possible weight, which is minus 0.5, and to set the third asset to the highest weight possible, which is 2.5. Notice that these sum to 1. Now note that there are other ways to check that the optimization was successful. Under status, we will get 0 if the program was successful, and we will also get true under success. So you can check either of these, and you can check the message, and these will all tell you whether or not the program was successful. Sometimes your linear program may not be successful, for example, if you pass in constraints that are impossible to meet. As an example of that, suppose you say you want your weights to be greater than 1 and less than 0. Of course, it's not possible for a number to be greater than 1 and less than 0 simultaneously. In the next block, we obtain the optimal value of the objective by calling res.fun. We'll assign that to a variable called minReturn. Next, we can run a linear program to find the maximum return. Since linprog does minimization by default, all we need to do is negate the mean return vector. So let's run this. Okay, and we see that this has also terminated successfully. Now, you might find this output strange. The optimal value of our objective looks to be minus 0.18. But how can that be if we are maximizing the return? Surely we had stocks that had positive return. In fact, this is because we just optimized the negative of the return. Therefore, the negative of this is the actual return, which is positive 0.18. So in the next block, we set max return to be negative res.fun. Next, we print out the min return and the max return one last time. So approximately minus 0.2 and plus 0.2.